Welcome everyone. Question number 251. Consider the following factors. Factors 1 initial pre-stress, 2 losses in pre-stress, 3 depth of cable from the extreme compression fiber. Those which affect the ultimate moment capacity of a pre-stressed concrete beam would include, suppose this is a rectangular pre-stressed concrete beam section of depth of width B and the depth of center of tensile reinforcement is DST from the top, and depth of center of the tendons from the top is DP, and this is the strain diagram linear. The strain at here will be epsilon naught, the strain at here epsilon naught, and strain at this level center of the tendon will be epsilon CP, and strain at the level of tensile steel will be epsilon S. Here is the stress diagram of this section. This is the stress block. Okay, the depth of the stress block will be gamma into dn. Dn is the neutral axis depth from the top of the beam section. Gamma is the factor that is dependent on the concrete strength, and its value varies from 0.65 to 85, and this value is 0.85 FC dash. FC dash is the concrete's compressive strength, and below the neutral axis this stress is pre-stress sigma pu, and this stress FSY is the tensile force exerted by the tensile steel from this beam section. So the moment of resistance or ultimate moment capacity of the beam will be stress into lever arm. So this is the rectangular section, so the center of this section will be at the middle. So from here to this force, this will be one lever arm, and from the center of the stress block to here, this will be another lever arm. Okay, so if we calculate the moment capacity in first case by the pre-stress force, the moment will be sigma pu into ap, area of tendon steel. Sigma pu is the pre-stress force, and the lever arm depth z1 will be dp minus gamma into dn by 2 plus the moment by the tensile steel will be FSY, force into AST, area of tensile steel, into the lever arm Z2 will be DST minus gamma into dn by 2. Okay, so clearly we can say the moment capacity of the pre-stressed beam is dependent on the depth of the cable, that is DP. Option D is right answer, 3 alone. Question number 252. Ultimate of a singly reinforced balanced RCC rectangular beam section is, as per IS 456/2000, the limiting moment of resistance MU limit is equal to 0.36 XU max by D into 1 minus 0.42 XU max by D into BD square FCK. This is the fundamental equation, and as per clause 38.1 we get the value of XU max by D in respect of Fy. So for AP250, XU max by D value will be 0.53, and for AP415 the value will be 0.48, and for AP500 the value will be 0.46. So if we put the value XU max by D equal to 0.48 in this equation, so MU limit will be 0.138 FCK BD square. Option B is right answer. Question number 253. Limit state of serviceability of pre-stressed concrete section should satisfy cracking, deflection and maximum compression. Option A is right answer. Question number 254. At limit state of collapse in shear, in case of wave shear cracks, it is assumed that the concrete cracks when the maximum principal tensile stress exceeds a value of Ft equal to 0.24 into root over FCK. Option A is right answer. At limit state, the principal stress exceeds a value of 0.25 FCK, and in WSN method, the principal stress exceeds the value of 0.16 into root over FCK. Question number 255. The loads to be taken corresponding to limit state of strength, reflection and crack width are respectively. Option D is right answer. Ultimate load, working load and working load. For strength, the design load is factored by partial factor of safety considering various load combinations. like dead load, live load, and possibly wind load or earthquake load. And for deflection, the service load, which is the actual load the structure is expected to experience, is used. Similarly, for crack width, the service load is also the primary consideration. So option D is right answer. Ultimate load in case of limit states of strength, and working load in case of limit state of deflection, and working load in case of limit states of deflection and crack width. Question number 256. A reinforced concrete beam is designed for the limit state of collapse in flexure and shear. Which of the following limit states of serviceability have to be checked? 1. Deflection, 2. Cracking, and 3. Durability. The acceptable limit for the safety and serviceability requirements before failure is called a limit state. There are two main limit states, which are: number 1, limit state of collapse. To satisfy limit state of collapse, the structure must be adequate to carry the load. It includes flexure, compression, tension, and shear. And second one is limit state of serviceability. It includes, to satisfy the limit state of serviceability, deflection, cracking, and vibration are must be within the permissible limits. It includes deflection, cracking, and vibration.
So correct code will be 1 and 2.
Question number 257. Match list 1 with list 2 and select the correct answer using the codes given below the lists. In list 1, a doubly reinforced section, reduction in sectional depth. 3 in list 2. Next in list 1, limit state design for ultimate moment capacity. 4. C, minimum cover is for durability in list 2. And in list 1, span by depth ratio capital D will be equal to serviceability in list 1. Question number 258. The bending moment at the edges of a square vertical bunker due to a lateral pressure P per unit area is. Vertical bunkers are the storage-like structures, and they are used for storing cement, grains, coal, etc. The bending moment at the edges of a square vertical bunker due to lateral pressure P per unit area is PL square by 12, and at the center it will be PL square by 24.
Option A is right answer.
Question number 259. Match list 1 with list 2 and select the correct answer using the codes given below. In list 1, continuous bridges, which is used for large spans. In list 1, causeways, capital B, to allow flood water to pass over. And in list 1, capital C, economic span, that is used for deciding the number of piers.
Option D in list 1, viaduct. Viaduct is a specific type of bridge designed to carry road or railways over long span, usually across uneven terrain. So option 2 in list 2.
Question number 260. In concrete bridge design, the impact factor for class A and B vehicle is equal to 0.5 when the span of the bridge is less than 3 meter, and the impact factor will be 4.5 by L plus 6 when the span is less than 45 meter but greater than 3 meter, and impact factor is equal to 0.08 for L equal to L greater than 45 meter. And impact factor for class AA and 70 are wheel class vehicle. The impact factor will be 0.25 when the span is less than 12 meter, and impact factor is equal to 4.5 by L plus 6 when the span is less than 45 meter but greater than 12 meter. And impact factor will be 0.08 for span greater than 45 meter. So for span greater than 45 meter, the impact factor value will be, both class is same, 0.08 for class AA and 70R, and for class A and B the impact factor is 0.08 for span greater than 45 meter. Option D is right answer. Question number 261. For Coulom's reaction coefficient to be valid, there should be at least 5 transverse beams. Option A is right answer. Question number 262. Consider the following statements for over-reinforced, singly reinforced rectangular RCC section. Statement 1. Lever arm will be less than that for a balanced section.
Right.
Statement 2. The maximum stress developed by steel would equal the allowable stress in steel.
Wrong.
Statement 3. The maximum stress developed by concrete would equal allowable stress in concrete.
No.
The section where the steel is more in quantity as compared to balanced section is called over-reinforced section. The lever arm will be less than that for a balanced section in case of over-reinforced rectangular RCC section. Okay, and the maximum stress developed by the concrete would be would equal the allowable stress in concrete, but the maximum stress developed by the steel would not equal the allowable stress in steel, because the concrete is less, so the pressure will be transferred on concrete only, so concrete will reach to its allowable stress before the steel does. So option B is right answer. Question number 263. The effective depth of a singly reinforced rectangular beam is 30 cm. The section is over reinforced and the neutral axis is 12 cm below the top. If the maximum stress attained by concrete is 50 kg per centimeter square and the modular ratio is 18, then the stress developed in the steel would be. This is the rectangular reinforced rectangular beam section. Okay, the effective depth, that is the distance from the center of the tensile steel to the extreme top fiber, that is small d equal to 30 centimeter. This is neutral axis. Okay, and this is the stress diagram. The maximum stress of concrete at this level is sigma cbc, which is given 50 kg per centimeter square, and neutral axis is at 12 centimeter from the top, so n equal to 12 centimeter, and equivalent concrete strength at this level will be sigma st by m. M is the modular ratio, that is equal to 280 by 3 sigma cbc, but here 18 is given, so by this similar triangle we can write sigma cbc by n, which is equal to sigma st by m equal to d minus n. Now putting all the value into the equation, we will get sigma st equal to 1350 kg per centimeter square. Option C is right answer. Question number 264. For plain concrete used in underground works of moderate exposure condition, the minimum cement content in kg per meter cube of this concrete mix would be. Option B is right answer, 250. Question number 265. Which of the following statements about the percentage of tensile steel required to produce a balanced reinforced concrete section is correct? The required percentage of steel reduces as the yield strength of steel increases. Option A is right answer. Question number 266. Which of the following are not dependent on the applied load? Elastic strain, creep strain, drying shrinkage, carbonation shrinkage. We know the deformation made into the body by the applied load is called strain. When it is up to elastic limit, that is called elastic strain, which is restorable in nature, but in case of plastic strain, the deformation will be permanent.
That is non-restorable.
And creep strain, which is a time dependent deformation of a solid material or structure under constant loading. Next, dry shrinkage strain. Dry shrinkage strain occurs in hardened concrete due to loss of moisture. Then carbonation shrinkage. Carbonation shrinkage is a type of concrete shrinkage that occurs when hardened concrete reacts with atmospheric carbon dioxide, and the reaction leads to formation of calcium carbonate, which has smaller volume than original calcium hydroxide, causing a reduction in volume of concrete. So drying shrinkage strain and carbonation shrinkage strain both are not dependent on the applied load. Option C is right answer. Question number 267. Marcus correction is introduced as simple correction to moments obtained by the Rankine's Grashof method to allow for corner restraint at corners and for assistance given by the torsion. In Rankine's Grashof method, the effect of restraint against the lifting of the corners and the effect of torsion in the slab are neglected. Marcus has given an approximate method for determining bending moment in slabs, simply supported on four edges with corners prevented from being lifted, and considering torsion in the slab. In this method, thickness of the slab is generally taken to be 1/30th of a shorter span.
Option C is right answer.
Question number 268. The radial moment at the boundary of a simply supported circular slab of radius capital R subjected to a uniformly distributed load of W will be. Suppose this is the circular slab. Okay, this is the radius of the slab is capital R. So if we take a section AB, okay, the slab subjected to uniformly distributed load, the beam will look like this. Simply supported beam subjected to uniformly distributed load. So bending moment at the boundary, that means at the end A and B will be 0. Okay, and the maximum moment at this point center will be 3W r square by 16, but the radial moment or at the boundary will be 0. Option D is right answer. Question number 269. The hoop stress in a dome subjected to uniformly distributed load is tensile at section whose radius vector are at an angle greater than 51 degree 51 minute with vertical. Option C is right answer. Suppose this is the RCC dome structure, curved shaped structure, very cost effective. Along this vertical direction, this is meridional forces are acting, and along this direction hoop forces are acting.
The hoop stress in a dome subjected to UDL is tensile at all sections whose radius vector are at an angle greater than 51.51 degree with the vertical. This is because in a spherical dome under UDL the vertical force is compressive while the hoop force changes from compressive at the crown to the tensile beyond the angle of approximately 51.51 degree from the vertical. The hoop stress is directly related to hoop forces. Therefore, the hoop stress is tensile in the lower portion of the dome.
Question number 270. For the normally used value of material properties and curing conditions, the maximum percentage of loss of pre-stress in post-tension concrete occurs due to creep and shrinkage of concrete. Option B is right answer. Question number 271. Concordant profile represents for a certain set of external loads to some scale the bending moment diagram. Option A is right answer. Question number 272. The loss of pre-stress due to shrinkage of concrete is the product of modulus of elasticity of steel and shrinkage of concrete. Option C is right answer. Question number 273. For a given grade of steel, the limiting reinforcement index for a singly reinforced beam is proportional to. We know the formula. Percentage of steel at limiting state will be equal to 0.36 FCK by 0.87 Fy into X will limit by effective depth D. FCK is the characteristic compressive strength of concrete and Fy is the yield strength of steel. So clearly we can say percentage of tensile steel at limiting condition is proportional to FCK. So option A is right answer. Question number 274. While applying the Winter and Pease method of analysis to folded plates, displacements of the junction of the heaped plate can be ignored if the span by depth ratio is less than 4. Option D is right answer. The Winter and Pease method of analysis is used to analyze the folded plates, which are a type of structural element commonly used in the construction. This method allows engineers to determine the internal forces and stresses within the folded plates. Question number 275. Minimum clear covered in mm to the main steel bars in slab, beam, column and footing respectively are 15, 25, 45, 40 and 75. Option B is right answer. Question number 276. The main reinforcement of a RCC slab consists of 10 mm bars at 10 cm spacing. If it is desired to replace 10 mm bars by 12 mm bars, then the spacing of 12 mm bars should be. So in first cases the area of the bar will be pi by 4 into 10 square, that is equal to 25 pi millimeter square, and the spacing S1 is equal to 10 centimeter. And in second case the area A2 will be pi by 4 into 12 square, so A2 will be 36 pi millimeter square, and S2 will have to be determined. So A1 by S1 is equal to 25 pi by 10, that is equation 1, and A2 by S2 is equal to 36 pi by S2, which is equation number 2. So from the question we can say equation 1 is equal to equation 2. So if we do that, we will get S2 is equal to 14.4 centimeter. Option C is right answer, 14.40 centimeter. Question number 277. Which of the following statement is correct? Statement A. Maximum longitudinal reinforcement is in an axially loaded short column is 6% of the gross cross-sectional area.
Correct. Minimum percent is 0.8% and maximum percentage is 6%.
Statement B. Column with circular section are provided transverse reinforcement of helical type only.
Not only helical type transverse reinforcement is provided, also the circular lateral ties is provided.
Statement C. Spacing of lateral ties cannot be more than 16 times the diameter of the tie bar.
The spacing of lateral ties should be lesser of the least lateral dimension of the column and the 16 times the smallest diameter of the longitudinal bar and 300 mm.
Statement D. Longitudinal reinforcement bar need not be in contact with lateral ties.
Longitudinal reinforcement should be in contact with lateral ties as it prevents the longitudinal reinforcement from buckling.
Question number 278. Torsion resisting capacity of a given RCC section increases with the increase in stirrup and longitudinal steels. Option D is right answer. Question number 279. If a simply supported concrete beam pre-staged with a force of 2500 kN is designed by load balancing concept for an effective span of 10 meter and to carry a total load of 40 kN per meter, the central dip of the cable profile should be. So this is a simply supported concrete beam pre-staged by a force of 2500 kN. Here is the neutral axis, and under this force the profile of the cable will be parabolic. So the question is asked here, what will be the central dip of the cable profile? Okay, this is Emax. Maximum dip is at here center of the beam. The beam is loaded with 40 kN per meter UDL and having a span of 10 meter. Now see the load or the bending moment under this load will be counteracted by the pre-stress force, okay, or pre-stress moment. So the moment with the load, the moment under the load M equal to the moment under the pre-stress force, that is equal to P into Emax, that is equation number 1. Okay, so the moment under the loading will be WL square by 8 for this beam, which is equal to pre-stress force P into P equal to 2500 kN into Emax, which will have to be determined. Okay, we know the load is 40 kN per meter over this beam and length is 10 meter. So by putting all the value, we will get Emax or dip of the cable is equal to 0.2 meter or 200 mm. Option B is right answer, 200 mm. Question number 280. In case of pre-tension RCC beam, shrinkage of concrete is of the order of 3 into 10 to the power minus 4. Option A is right answer. Question number 281. For pre-stressed structural elements, high strength concrete is used primarily because of high modulus of elasticity and low creep. Option D is right answer. Question number 282. Pre-stressed concrete is more desirable in case of cylindrical pipe subjected to internal fluid pressure,
Because pre-stressed concrete can withstand the tensile stress induced by the pressure, which can cause cracks and failure in case of ordinary concrete pipes. Option A is right answer.
Number 283. Yield line theory results in upper bound solution. Option C is right answer.
Yield line theory results in an upper bound solution for the collapse load of reinforced concrete slabs. This means that the calculated collapse load is likely to be higher than the actual collapse load, providing a safe but potentially conservative estimate. And in case of lower bound theorem, the stress at any point within the structure does not exceed the material's limit. The load created is a lower bound to the actual collapse load.
Question number 284. If the nominal shear stress at a section does not exceed the permissible shear stress tau c, the minimum shear reinforcement is still provided. Option A is right answer. Question number 285. Consider the following statements concerning both working stress design and ultimate strength design of reinforced concrete. Statement A. Plane section before bending remains plane after bending. Statement 2. The tensile strength of concrete is ignored. Option C is right answer. Both 1 and 2 are correct. Question number 286. In limit state design, permissible bond stress in case of deformed bars is more than that in plain bars by 60%. Option A is right answer. Question number 287. If FCU and FY are cube compressive strength of concrete and yield stress of steel respectively, and ES is the modulus of elasticity of steel for all grades of concrete, the ultimate flexural strain in concrete can be taken as. Option C is right answer, 0.0035. Question number 288. Limit state of serviceability for deflection including the effect due to creep, shrinkage and temperature occurring after the erection of partition and application of finishes as applicable to the floor and roof is restricted to span by 350. Option D is right answer. And the final deflection due to all load including effects of temperature, creep and shrinkage and measured from the cast level of support and floors, roofs and all other horizontal members shall not exceed normally span by 250. Question number 289. Shrinkage deflection in case of rectangular beams and slabs can be eliminated by putting compression steel equal to tensile steel. Option A is right answer. Question number 290. In case of two-way slab, the limiting deflection of the slab is primarily a function of the shorter span. Option B is right answer. Question number 291. From limiting deflection point of view, use of high strength steel in RCC beam results in increase in depth. Option C is right answer. Question number 292. for maximum sagging bending moment at support in a continuous RCC beam, live load should be placed on. So consider a continuous beam ABCDEF with end span AB and EF and intermediate span BCCD. Now if we take an imaginary hinge at X of the span BC and apply a pair of positive bending moment adjacent to the both side of the hinges, the deflected shape of the beam will be like this. So from this deflected shape we can say, to get maximum sagging moment, the live load should be placed the same span as well as the alternate span. Spans next to the adjacent spans of the support plus alternate spans. Option C is right answer. Question number 293. Design of one-way RCC slab for concentrated load is done by taking slab strip of width effective in resisting the load. Option C is right answer. Question number 294. In Pigot's coefficient method for the analysis of an interior panel of a T-beam bridge, the applicability is restricted to the case when the wheel load is centrally placed. Option C is right answer. Question number 295. A T-beam roof section has the following particulars: thickness of the slab is equal to 100 mm, width of the roof 300 mm, depth of the beam 500 mm, center to center distance of the beam 3 meter, effective span of the beam 6 meter. Distance between the points of contact flexure is 3.6 meter. The effective width of the flange of the beam is. So we got thickness of the flange of the T beam is equal to 100 mm, and the depth of the T beam is 500 mm, and the breadth and the width of the rib or wave thickness is 300 mm. So breadth of flange will be L0 by 6 plus BW plus 6 into TF. So TF is equal to 100 mm, BW is equal to 300 mm, and L0 is 3600 mm. So by putting all the value we will get breadth of flange BF is equal to 1500 mm. Option D is right answer. Question number 296. Match list 1 with list 2 regarding the minimum concrete cover to the reinforcing steel and select the correct answer using the codes given below the list. List 1. Capital A. For longitudinal reinforcement in column of sizes 200 mm and less with 12 mm diameter bars as longitudinal steel. In list 2 the cover will be 25 mm. In list 1 capital B, for longitudinal reinforcement in beams, the cover will be 25 mm or diameter of the bar, whichever is more. In list 1 capital C, for longitudinal bars in slab, the cover will be 15 mm or diameter of the bar, whichever is more. In list 2, in list 1 option capital D, for longitudinal bars in column of sizes more than 200 mm, the cover will be 40 mm or diameter of the bar, whichever is more. In list 2, so option A is right answer. Question number 297. Minimum percentage of area of HYSD reinforcement in a 150 mm thick water tank wall is. Option C is right answer. Question number 298. In a load balanced pre-stressed concrete beam under the self load, the cross section is subjected to. Question number 299. A pre-stressed concrete beam 150 mm into 300 mm supports a live load of 5 kN per meter over a simply supported span of 8 meter. It has a parabolic cable having an eccentricity of 75 mm at mid span and 0 at the ends. The pre-stressing force required to maintain the net resultant stress at the bottom fiber at mid span as 0 under the action of dead load and live load plus pre-stress is. So friends, suppose this is a pre-stressed concrete beam subjected to a dead load and live load and subjected to pre-stress force P. Okay, and the pre-stressed concrete beam have a cable profile that is parabolic in nature. The central dip of the cable and midspan will be 75 mm, which is the E maximum, and 0 at both ends. Okay, now if we consider the section under the pre-stress force and area of this section and eccentricity and section modulus Z and moment under dead load and moment under live load, the net resultant stress at top fiber will be P by A minus PE by Z plus MDL by Z plus MLL by Z, and resultant stress at bottom fiber will be P by A plus PE by Z minus MDL by Z minus MLL by Z. MDL and MLL is the bending moment of dead load and live load. of the beam respectively. So we have got net resultant stress at the bottom fiber, which is equal to P into 1 by A plus E by Z, which will be equal to MDL plus MLL by Z. It is equation number 1. Now from the question we have got E equal to 75 mm, that is the maximum. Area of the section 150 into 300 mm, that is equal to 45000 mm square, and dead load of the beam 0.15 into 0.3 into 25. So dead load will be equal to 1.125 kN per meter. 25 is the unit weight of RCC. Now section modulus for this section will be BD square by 6, which is equal to 150 into 300 square by 6, that will be equal to 2.25 into 10 to the power 6 M.C.Q. Now total bending moment under dead load and live load will be total load 1.25 plus 5 into 8 square by 8 W square by 8. The total moment value will be 49 into 10 to the power 6 Newton millimeter. By putting all the value in equation number 1, we will get P is equal to 392 kilonewton. Option D is right answer, 392 kilonewton. Question number 300. A partially pre-stressed member is the one in which tensile stresses and crackings are permitted under service loads. Option A is right answer.